Now the next type of equations we're going to be dealing with have fractions and they involve multiple steps. For example, on number 1 here we have k fifths minus 1/2 equals 3/2. So we have a lot more going on here. We're going to do this one separately on the blackboard. Now the first step is to always remove whatever's being added or subtracted. We did that when we were working the problems that didn't involve fractions. So we have 1/2 being subtracted from k. So we're going to have to first add 1/2. That's what will cancel out the minus 1/2. So I'm going to add 1/2 because whatever you do to one side, you have to do to the other. Of course, on the left side, that would just leave me k fifths. This is going to cancel out. That's why we did it. Equals 3/2 plus 1/2, which is 4/2. Now 4/2, that should look familiar. That's just another way of writing 2 because 4 divided by 2 is 2. Now we only have one more step to get k by itself. K is being divided by 5, so the opposite of that would be to multiply by 5. Now the reason why it cancels out is because this 5 is in the numerator and it's going to cancel out with the 5 in the denominator. So we're going to have 1k or k equals 10, and that's our answer there. Now this one's a little bit different. The whole expression, the whole numerator is over 4 this time. And in this case, we can't do anything until we get it out of fraction form. So one way to do it is to multiply everything by the denominator, which is 4. So I'm going to multiply both sides by 4. Now what happens over here is I do not need to distribute this 4 because this 4 is in the numerator. You can look at this as 4 over 1. And it's going to cancel out with this 4 in the denominator. That's why we multiplied by 4. And that's just going to leave us a 1 times x minus 4, which is x minus 4. And on the right side, we're going to have negative 12. Now from here, it's fairly simple. To solve for x, we just add 4 to both sides, and that's going to give us the answer, which is x equals negative 8. Now remember the difference between examples 1 and 2. On example 1, these are separate fractions, so I just moved the 1 away first. But on example 2, the whole thing was in fraction form, and I had to get it out of fraction form by multiplying through by that denominator. So that gave me the answer, x equals negative 8. Okay, now looking back on our notes, under the try these on page 5, we have this first example right here. This is 5x plus 10 over 7 equals 0. This is very similar to the example we just did. So first, we want to notice that the whole thing, the whole numerator here, is over 5x plus 10. So we're going to have to get that out of fraction form here, and we're going to multiply both sides by 7. Okay? Now by multiplying both sides by 7, that's what I'm doing, the 7 in the numerator will cancel out with the 7 in the denominator. So I'm not going to have to rewrite that again. And then what I'll have is I'll just have 5x plus 10 equals 0, because in this case I'm multiplying 7 times 0, which is just 0. And then solving from there is very basic. You subtract 10, divide by 5, and you get negative 2. This one's also similar. The whole thing is in fraction form. And so you can't just add 1 to both sides because it's not just 1. It's 1 over 3. You have to get it out of fraction form. So I multiplied both sides by 3, and this 3 in the numerator cancels out with the 3 in the denominator, so we do not need to distribute it. We just bring down the 2x minus 1 equals the negative 15 that we got after multiplying those two together. And you can solve it from there. Now, going back to our blackboard, on example 3 here, this one's a little different because these are separate terms. The whole thing is not over 3, so we don't have to worry about getting out of fraction form to begin with. What we're going to do is we're going to follow the same steps that we normally do. We're going to get rid of the 1s. We're going to try to get the z term by itself by moving whatever's being added or subtracted. So I'm going to subtract 3 from both sides. And that'll give me 5z3, or 5/3 z, equals negative 5. So those cancel out. Now another way to look at this is the same as 5/3 z equals negative 5. So you can just multiply by the reciprocal here, because remember, instead of dividing by 5/3, because that's what you need to do, you're multiplying by 5/3, so you would divide by 5/3. But dividing is the same as multiplying by the reciprocal, which is 3/5. So I'm going to multiply by the reciprocal 3/5 on both sides. So when you have a fraction being multiplied, you can just multiply by the reciprocal. And the 3 over the 3 and the 5 over 5 cancel out, leave me z equals, well, let's multiply negative 5 times 3/5. I'm going to put negative 5 over 1 to make it a fraction. And you can see that the 5's would cancel each other out, and I would be left with negative 3 over 1, which is just negative 3. And there's my answer there. Now another example that's a little bit different is example 5 from the notes. Now in this one it's different because I have two different fractions here. But I cannot do anything with the 5a minus 2 in the numerator until I get it out of fraction form. So there's a couple different ways to do this, but what I'm going to do is I'm going to go ahead and multiply by the 3. That way I have it out of fraction form. So let's do that. I'm going to have, when I multiply the left side by 3 in the numerator, it cancels out with the 3 in the denominator, and so all I'm left with is 5a minus 2 there. Now over here I've got to multiply by 3 also. Now 3 times 1/6 is going to be 3/6, but that reduces to 1/2. Because if you're multiplying, you see the 3 goes in 3 one time and the 3 goes in the 6 two times, so it's going to reduce to 1/2. Now all I have to do is add 2 to both sides to get a by itself, and I'll have 5a equals, let's add this over here, scratch work. We have 1/2 plus 2. Now I'm going to put it over 1 to make it look like a fraction, and I'm going to find a common denominator. Remember, as you're working these problems, perform the same steps that you normally would, and just do your scratch work for the fractions on the side. Okay, do that on the side, that way you don't get it all mixed in with the equation. So I'm going to do my scratch work over here. I have 1/2 plus 2 over 1. Well, a common denominator between 2 and 1 is just 2, so I'm going to leave this as 1/2. And I'm going to change this to, well, let's see, if I need this to be a denominator of 2, I'd multiply it by 2. So I'm going to multiply 2 times 2 and get 4. And so now I have 1/2 plus 4/2, which is 5/2. Now I'm almost finished. This time I have 5a equals 5/2. So I could divide both sides by 5, but that's not really going to help me out a lot because I have a fraction over here. So instead of dividing by 5, which is the same as 5 over 1, let's multiply both sides by the reciprocal. So that's what I'm going to do. I'm going to take both sides and I'm going to multiply by the reciprocal, 1/5. And then we're almost done. And as you can see over here, everything cancels out, and I have 1a equals, this is going to cancel out, and I'll have 1/2, and that is my answer. Okay, and the last example I want to look at is example 6 from the notes. We have negative 8y plus 13 equals 24. Now at first glance, this seems like a regular equation, so you always move away whatever's being added or subtracted. So we're going to subtract 13 from both sides, and that would give us negative 8y equals 11. And then we divide both sides by negative 8, and that gives us positive y equals, well, the problem is that 8 does not divide into 11 evenly at all. And sometimes that'll happen, and you're just going to leave your answer as a fraction, negative 11/8. And it's okay to get a fraction as an answer because not all equations are going to work out to be integers. So that's a good review of how to do the equations that have multiple steps and that involve fractions.